In the early 2000s, China's space program was rapidly advancing, but the moon remained an elusive goal. With the US and Russia having led the charge in space exploration for decades, China was determined to prove its spacefaring capabilities to the world. The vision was ambitious. China sought to land on the moon, gather scientific data, and eventually return lunar samples to Earth. The Chang'e program, named after the Chinese moon goddess Chang'e, was announced in 2004. It was China's first major effort to send a spacecraft to the moon, and it signified the beginning of the country's long-term lunar exploration ambitions. Unlike many other space programs, China's lunar missions will be developed entirely in-house, drawing on its growing expertise in satellite technology and rocketry. The early years of the Chang'e program faced several hurdles. Limited resources, the pressure to keep pace with global space powers, and the challenge of developing the necessary technology to land on the moon. Despite these challenges, China's government invested heavily in space exploration, and the Chang'e missions were launched as part of a larger vision to establish China as a dominant space power. On October 24, 2007, China launched its first lunar probe, Chang'e 1. The mission was designed as a lunar orbiter to map the moon's surface, gather data on its mineral composition, and measure the moon's radiation environment. This was China's first significant step in the Chang'e program, and it carried the weight of a national space ambition. The technical challenges were enormous. China had never attempted an interplanetary mission before, and sending a spacecraft to orbit the moon required precision and coordination that had never been tested on such a scale. Yet, Chang'e 1 was a success. It entered lunar orbit in November 2007, and for the next year, the orbiter sent back critical data about the moon's surface, mapping over 2.5 million square kilometers. Chang'e 1 also helped prove China's ability to build and operate spacecraft for deep space missions. However, there were struggles behind the scenes, difficulty with communication systems, ensuring that the instruments were calibrated correctly, and adjusting to the vast distances involved. The success of Chang'e 1 marked a significant milestone for China's space program and set the stage for the next phase of the lunar journey. In 2010, China launched Chang'e 2, a more advanced version of its predecessor. This mission was designed to be more ambitious, acting not only as an orbiter but also preparing for the future of lunar exploration with a lunar lander in mind. Chang'e 2 was tasked with orbiting the moon and mapping its surface with higher precision, including detailed observations of potential landing sites. The mission's biggest achievement was the confirmation of the moon's South Pole Aitken Basin as a potential site for future landings. It also included tests for spacecraft rendezvous technology, which would be essential for the upcoming missions involving landers and return samples. While Chang'e 1 was primarily a data-gathering mission, Chang'e 2 was designed to expand China's understanding of lunar geography and technological capabilities. However, Chang'e 2 faced its own set of challenges. A key difficulty was the complexity of managing the spacecraft systems over long distances. Ensuring the orbiter could perform detailed scans, even in the absence of direct real-time communication, was a huge technological hurdle. Yet, the mission was deemed a success and went far beyond initial expectations, positioning China as a serious contender in the field of space exploration. In 2013, Chang'e 3 achieved what no Chinese spacecraft had done before. It successfully landed on the moon. This was China's first soft landing on the lunar surface, a major milestone in the Chang'e program and a significant achievement in the field of space exploration. The lander carried the U-2 Jade Rabbit rover, which would explore the surface, conduct experiments, and send images and data back to Earth. The mission's objective was to study the moon's surface, mineral composition, and geological structures. Despite the success of the landing, the mission was not without its struggles. The biggest challenge came with the U-2 rover. Shortly after landing, the rover experienced mechanical failure, which limited its mobility. The failure of a key wheel motor meant that U-2 could not travel long distances across the moon's surface. However, the rover still sent back valuable scientific data, including high-resolution images of the moon's surface and analysis of its composition. Chang'e 3 was a triumph for China, signaling its ability to land spacecraft on the moon and operate rovers in difficult terrain. However, the challenges of dealing with unforeseen technical failures were a reminder of how difficult lunar exploration can be. The success of Chang'e 3 set the stage for an even more ambitious mission, Chang'e 4. Launched in 2018, this mission would become the first spacecraft in history to land on the far side of the moon, the side that faces away from Earth and is never visible from our planet. The mission was groundbreaking, as no country had ever landed a spacecraft on the far side of the moon. The far side is a region of immense scientific interest because it is shielded from Earth's radio emissions, making it an ideal location for radio astronomy and other experiments. The Chang'e 4 mission faced significant technical and logistical challenges. The spacecraft had to communicate with Earth via a relay satellite, as the far side of the moon is out of direct line of sight from Earth. Ensuring the lander could survive the moon's harsh temperature fluctuations and managing the rover's operations remotely were also major hurdles. Despite these obstacles, the mission was a complete success. The U-2 rover successfully landed on the far side of the moon and began exploring. The rover has made significant contributions to lunar science, including studying the geology and mineral composition of the far side, which had never been explored by any spacecraft before. Chang'e 4 demonstrated China's growing capabilities in deep space exploration. In 2020, China took another giant leap by launching Chang'e 5, a mission designed to return lunar samples to Earth, a feat only accomplished before by the Soviet Union and the United States. This mission represented a culmination of China's technological advancements and a significant milestone in the Chang'e program. The spacecraft's task was to land on the moon, collect samples of lunar soil, and return them to Earth. It was a complex mission, involving the launch of a lander, a sample collection system, a return vehicle, and a re-entry capsule. The Chang'e 5 mission had to overcome numerous challenges, including ensuring the lander could collect soil samples from the moon's surface and then safely return them to Earth. The spacecraft successfully returned with 2 kilograms of lunar soil, marking China as the third country to accomplish this feat after the United States and the Soviet Union. The success of Chang'e 5 was not just a technological achievement, but also a symbol of China's rapid advancement in space exploration. It positioned China as a serious player in the global space race and demonstrated that it could compete with the leading space agencies of the world. The Chang'e missions have laid the foundation for China's future in space exploration. With Chang'e 6, Chang'e 7, and Chang'e 8 already in the works, China's ambitions continue to grow. These upcoming missions will focus on further lunar exploration, including sample return missions, lunar-based development, and perhaps the future of human missions to the moon. The Chang'e program has not only expanded China's space capabilities, but also fostered international collaboration, as China begins to share its research with other space agencies. The scientific discoveries made by the Chang'e spacecraft will continue to inspire and shape future generations of scientists and engineers. As China looks toward future lunar exploration and the colonization of the moon, the legacy of Chang'e will be one of resilience, innovation, and global leadership in space exploration. Conclusion. The Chang'e missions reflect China's rising power in space exploration and its determination to reach the moon and beyond. With each mission, China has overcome technical difficulties, made groundbreaking discoveries, and contributed significantly to the field of space science. As China continues its lunar exploration, the Chang'e program will remain a testament to the country's ambition, ingenuity, and vision for the future of space exploration.